This video is sponsored by codingskill.net. Please visit our sponsor. Write a program that takes any input and gives you any output. Let's work through a problem. The problem statement is, does a non-negative integer contain a particular digit? We are given a non-negative integer n and a digit that's between the range 0 and 9. Determine whether d is present in n. The given parameters are n and d. We are going to make an assumption that n does not contain any leading zeros. We will first look at linear recursive algorithm. We need to establish the size of the problem. The size of the problem is number of digits of n. The base case occurs when n only contains a single digit. If n is a single digit, we will return whether n is equal to d. In the recursive case, we reduce the size of the problem by a unit. Dividing n by 10 discards the least significant digit. Let's look at the recursion diagram for this problem. The inputs are n, which is sequence of digits, and the digit d. The result is the OR operation of whether d is in any of the digits of the given number n. In the reduction step, we chop off the last digit in n by dividing n by 10. The result of this smaller subproblem is the OR operation of checking whether d is in any of the digits in the reduced value of n. In the combination step, we need to chain another OR with the check for whether d naught equals d. If d is a digit of n, then it is either present in n over 10, the result of the recursive call, or it is equal to d naught. We can now look at the code. The contains method takes two parameters, n the number and d the digit that will be used to check whether it's in n. The base case checks for a single digit number and returns true or false depending on whether d and n are same digits or not. In the recursive case, we check if the least significant digit in n is d or not, and or that with the result of the recursive call. The value of n is reduced by chopping off the least significant digit in n by integer division by 10. There is one recursive call. This is a linear recursive Boolean function. Let's now look at the tail recursive algorithm. We will use short circuit evaluation. We add a second base case. We return as soon as a digit in n is equal to d. Therefore, return true if the last digit of n is equal to d. That is, if n modulo 10 is equal to d. We can now look at the code for the tail recursive algorithm. The base case is the same as before. We have a second base case that checks if the least significant digit of n is d. If so, we return true. Otherwise, we have recursive case that makes a recursive call with reduced input of n. Note that n modulo 10 equals d naught is not equal to D in this case. We can compare both versions of the code. Return value can be from base case or recursive case. In the first version, the return value is only from base case in the second version. You can see the recursion diagram differs from the previous version of the solution. The result of the subproblem is the output of the original problem. Function returns the result of the recursive call without processing it. That's why it's called tail recursion. The decomposition divides the input by a constant 10. The size of the problem is only reduced by a unit. The time complexity is linear with respect to the number of digits of n. Here is a similar problem. Decide if a string contains a character. Sign up for your free coding interview coaching call. Fuck. Sign up for your free coaching call by going to codinginterview.coach.